G'day team, welcome back to another video. So today we're going to kick off again with our vector work. Today we're going to be looking at vector addition and the zero vector. So you can see I've got a little bit of a example here. So vector addition doesn't quite work like this. We've got two vectors, so from Despicable Me. You can't just add two vectors together. We don't have vector plus vector equals two vectors, all right? There is a way we can do this though. So, bit of an example here. Suppose that there are three shops, A, B, and C. A trip from A to B, followed by a trip from B to C, has the same starting point, origin, and the same finishing point, destination, as a trip from A to C. All right, so from A to B and then B to C is the same as going from A to C. Okay, so as a vector sum, this looks like this. So A to B plus B to C equals A to C. All right, notice that we actually have the first starting point, so the origin of the first vector and the destination of the second vector are actually this origin and destination of the resultant vector. All right. So we can actually show this graphically, and it can take many forms. So I've done three examples here. So remember, we've gone from A to B, B to C, all right, and then that's the same as A to C. So the way we actually construct these diagrams of vector A plus vector B, for example, we follow the following steps. So we draw A. So in this example here, say this is our vector A. So we draw in vector A. All right. Step 2, at the arrowhead of A, we draw vector B. So we locate the arrowhead of A, and then we draw in whatever vector B is. And in this case, this is our vector B. All right. Step 3, join the beginning of A to the arrowhead end of B, and this is the vector A plus B. So that is our red line here. So I'm just going to write in A plus B. Okay, so that is how we actually draw these diagrams. So if you've got these three steps written down, you'll be more than fine constructing these diagrams. So, and another example here, given vectors A and B, construct A plus B. So following our steps, draw in A. At the arrowhead of A, we draw B, and then we connect from the base or the tip of A to the arrowhead of B, and that's our A plus B. All right. So the second thing I wanted to run through with you guys in this video was actually the zero vector. So the zero vector is a vector of length or magnitude 0. So for any vector A, we actually have a few results here. Okay. So over here, if we're starting in destination A and we're moving and finishing in destination A, then we've actually got the zero vector because we haven't actually gone anywhere, okay? The next one is exactly like how a regular zero affects a regular number. Vector A plus the zero vector equals the zero vector plus a vector A, which is just vector A, okay? Because we haven't moved anywhere. So then also, vector A plus negative vector A is equal to negative vector A plus vector A, which gives us our zero vector. It's just like if we have 2 take 3, 2 take 2 even, and then negative 2 plus 2, they equal 0. So it's the same property. And then when we write the zero vector by hand, we write 0 with our little vector symbol on top. So the second example I want to show you guys today is finding a single vector from a shape and a bunch of vector sums. So for A, we're looking at A to E plus E to D. So that would give us a resultant vector A to D. Remember, we can just look at this first letter here and this last letter here. So A to D. B, we're looking at C to B, B to E, and then E to A. So that is exactly the same as going from C to A, as we got C and A. And then finally, for question C, we're going to look at the first and the last, and we see that we've gone from B to B. So remember, if we're going from one place and we're staying in the same spot as our resultant, that is the 0 vector. All right, hopefully that gives you a bit of a guide into vector addition and the 0 vector. We'll catch you guys next time.